this video we will discuss about the voltage division and current division. To complete the previous video, to better understand, I request to see the previous video before seeing this video, because they are correlated. So we see in series, when I have element in series, let's say I have R1 and R2, which are alimented by one source Vs. We discussed the previous that this current will be supplied from this source is the same current will be flowing in I1, the same current will be flowing in I2. Mean that in series I have I1 equal I2. Now this one I have V1, the voltage across resistors R1, and I have V2, the voltage across resistors R2. So I will have, if I want to find V1, since they are series, means that the voltage this one is not the same voltage as this one, except if the resistors will be same, because since they flow the same currents, and from Ohm's law I know V equal RE, same currents from R1, the same current from R2, means that if the resistors are same, the voltage will be same. Otherwise, they will never be same. So how to determine the value of V1? To determine the value of V1, since they are in series, I will just to take the value, what's the resistors? R1, because I want to find V1, so it will be R1 multiplied by the value of Vs. The value of Vs is the voltage which supply both resistors, divided by R1 plus R2. R1 plus R2. If I had another 3 resistors here, it's going to be R1 plus R2 plus R3. Now, how to determine V2? V2 is going to be, since V1 I use the value of R1, so V2 I will use the value of R2. R2 multiplied by Vs divided by R1 plus R2. So now I know how to determine the value of V1 when it's in series. I know how to determine of V2 when it is in series. If I had a V3, you already know how to determine. I will use R3. Now we have to also to know that Vs, the voltage of this source, is equal to the voltage V1 plus V2. You have to know it to keep this one also, that the voltage of this one equals the voltage of this one plus the voltage of this one. Mean that if I know the voltage of this source, I know one voltage from one resistor, I can directly determine the voltage of the other resistor without using this one. Or if I know the voltage of V1, I know the voltage of V2, I can directly determine the value of Vs. Now, if we replace this one here, Vs is going to be equal, what's the value of V1? V1 it was R1 from voltage division, this one the voltage division, this one we call these two, we use this one is voltage division, this one the voltage division, the voltage division is when they are in series, because they are not same. Now from here I know that Vs equal, V1 plus V2. So Vs is going to be, what's the value of V1? Value of V1 is equal R1 multiplied by Vs divided by R1 plus R2 plus V2. What's the value of V2? V2 equal R2 multiplied by Vs divided by R1 plus R2. If you see the same denominator, both term, I can keep it outside. I will have R1 multiplied by R1 plus R2. What should remain? If you look at again, I will have what? Vs. I will have Vs. So I can put here, I will have Vs here, because I will have Vs here and Vs here. So I will put Vs. Now we remain R1 plus R2. So what will mean that I can just use the same V1 and same V2 by using this two formula. Now this one is the voltage division, this one is the voltage division. Now let's say, for example, now if we are in parallel, the elements are in parallel. So when the elements are in parallel, we already discussed in the previous video that in parallel, for example, this one we have the R1, this one have the source V, have R1, I have R2. Now this R1 and R2 are what? Are in parallel. Why? Because they are not flowing the same currents. I1, I2. Secondly, they are same connected with the same node. The node we will discuss in the next video. Now the voltage across V2 and the voltage V1 are same. We already discussed that V1 equal V2 equal the Vs, because Vs also is parallel with them. Now I cannot talk about voltage division, because there is no division. The voltage is same, but is the current who is divided. That's what we call, now I will call current division. Current division in parallel I will talk about current division because the voltage is shown. In series I will talk about voltage division. I will not talk about current division because the current is flowing the flow is the same. Now in the current division means that I have to determine I1, which is the current flowing in R1, which is going to be equal. In this case I will take the opposite resistor. Now since I want to find I1, I will take the resistor R2. I will have R2 multiplied by IS, which is IS. IS is the total currents, the currents which be produced by the source, divided by R1 plus R2. Now if I want to find I2, I will take the opposite. I2 is the current flowing R2, so I have to take the opposite resistor, and I will have R1 multiplied by IS. I will have I2 equal R1. Since I want to find the resistor, the current flow in R2, I will take the opposite. R1 multiplied by IS divided by R1 plus R2. Now I determine the total currents. We have to keep in mind like the current IS equal I1 plus I2. So that is the current division. We'll talk current division in parallel, and we'll talk voltage division in series. We already determined the voltage division in the previous video. Now we are going to talk about, as I mentioned in previous, what we call node. We'll talk about node, we'll talk about branch, we'll talk about loop. Now a node is a joint of wires. Mean that if I have this one, I have this one, I have this one. This is wire, this is wire, this is wire. So this joint we call this a node. If I have this one, I have this one, and that this one is a node. This one is a node because I join here and I join here in this by this joint. Now branch it is element. Branch is element. It can be resistor or capacitor, any. Mean that I have this branch, I have this branch. That is called branch. Now loop it is a closed path. Let's say for example I have this circuit, which alimented by this source. I have this one, I have R1 here. Yes, I have this one, R2. I have R2 here, I have R3, I have R4. Mean that this one is a loop because it's closed path. This one also is a loop because it is closed path. This one also is a loop because it is closed path. Whole from here to here, the whole, that is also a loop. So we have this loop, we have this loop, we have this loop, we have the biggest loop. That is the loop and node and the branch. Now we are going to see what we call Kirchhoff laws. We are going to see Kirchhoff laws. In the Kirchhoff laws, there is two laws. We have KCL, which stand like Kirchhoff current law. What does it stand? Kirchhoff current law, KCL, is stated that in a node, we already discussed about node. In a node, summation of current entering equal summation of currents leaving. Mean that if, let's say for example, I have this node, we already discussed about node, everyone know. In this node I have this current I1, I have this current I2, I have this current I3, I have this current I4, I have this current I5. I have to see, I am in this node, this current is entering, I1 is entering, I1. Which current also is entering? If I see this current I3 is entering, mean that summation of current entering, mean that I1 plus I3 equal, there is no another current which is entering, equal summation of the currents leaving. This current is leaving, this one is going to be I2 plus, which current also is leaving? This I3 is leaving, plus I3 plus I4 is leaving. So that is the KCL. Mean that in a node, summation of the currents entering equal the summation of currents leaving. This current entering, this current also entering, mean that when both are entering, they are going to be separated, meaning that the summation of this one plus this one equal the summation of the currents leaving. Meaning that if I have this one, I have this one, I have this one, I have this one, I can determine I3. Now, that's the KCL. Now, we're going to see the KVL. KVL. What does the KVL say? The KVL say that in a closed loop, in a closed part or closed loop, in a loop, summation of voltage equals 0. Now let's see. I have this source, I have this one, I have this one, I have V1, I have this one, V2, I have Vs. So KVL, which is 10 Kirchhoff voltage law, we say that summation of the voltage across a loop equals 0. Mean that I will have in this arrow will follow this arrow. This arrow is entering the negative. I will have minus Vs. I will take the first sign. This arrow entering the negative. I will have minus Vs. The arrow, if I follow again, is entering this positive, plus V1. This arrow, if I follow again, is entering this positive, plus V2 is going to be equal is going to be equal 0. That is the voltage. Mean that the KVL. Mean that in a loop, summation of the voltage is equal 0. If I put this arrow, the first one is entering in this source is negative. The arrow is entering the negative. I will have minus Vs. This source is entering. The arrow is entering this positive. I will have plus V1. This arrow is entering this positive. I will have plus V2. I will have plus V2. So equal 0. Equals, that is the KCL and KVL. Next video we will see some example about the KCL and the KVL for better understanding. Thank you for watching.